So displacement time graphs and velocity time graphs. I won't be going into detail of explaining the difference between displacement and distance and velocity or speed. That is understood, that we have covered in the vectors lecture. Are we okay? Are we comfortable?
Yeah.
Okay. So, the crux of this lecture is that if I give you a velocity time graph, or if I give you a displacement time graph. So, if I give you a graph like this, that this is a velocity time graph, and if I give you a graph like this, which is a displacement time graph, the first thing that you need to understand very clearly is that usually on the x-axis time would be there, but the confusion would be regarding what is there on the y-axis, because we will be dealing with two kind of graphs. There can be uh, on the y-axis there can either be displacement or there can be velocity. So we should be very clear what kind of graph are we dealing with. Are we okay till here?
Yeah.
So this is the first thing that you need to understand, that on the y-axis whether we are dealing with displacement or we are dealing with velocity. Are we clear?
Yes, sir.
So first thing that we need to understand is what kind of graph we are dealing with, what kind of graph, what kind of graph. And the second thing that we need to understand is that when we are reading these graphs, there will be two kind of things that we'll be worried about. One would be slope, other would be area. Of course, we'll be going into the detail, but I just want to tell you that the crux of the lecture lies in these two details. One, what is the kind of graph that you are dealing with? And second, what information can I get from the slope of that curve, and what kind of information can I get from area under the curve? Are we okay till here?
Yeah.
Okay. Now, before I even start the lecture, I will be sharing this playlist with you. The lecture that you'll have to do, the solved problems that you'll have to do, I'll mark that in the when I send you the playlist. But just for your reference, you'll have to do this 14.31 lecture. Have you understood?
Okay. Yeah.
You'll have to do this 7.28 lecture.
Okay.
You'll have to do this 11.15 lecture. You'll have to do the 12.54 lecture, 12.22 lecture, and 11.30 lecture. These are the lectures. They belong to specifically velocity time graphs. Are we clear till here?
Yeah.
I will mark the lectures that you will have to see. You have 3 days. So all these lectures are solved numericals and given some conceptual gyan also. So they will help you to understand in detail about how to deal with these kind of graphs. Yeah, are we clear till here?
Yes, sir.
Okay. So I'll start with very basic facts that we have understood from maths, class 10th maths. So one is that the slope of a line, if these are the 2 points on a line, x1, y1 and x2, y2, these are 2 points on a line, and if I want the slope of the line is given by y2 minus y1 upon x2 minus x1. Is there any doubt about this?
No.
This is how I find the slope of a line. Slope of a line. Now, the second thing that we need to understand is how to find the area under the line. When in physics, in motion chapter, they talk about the area under the line. What they are trying to tell you is that, for example, let me take an example. So, for example, this is the kind of curve they give you for a velocity time. The curve will look something like this. They'll give you this information. So, from point A to B, from point B to C, from point C to D. So A to B, they will call as, let us assume, the part 1 of the motion. B to C would be part 2 of the motion, and C to D is part 3 of the motion. Are we clear till here?
Yeah.
So they will ask you, the kind of questions they will ask you is that in the first phase, that is from A to B, what is the slope of the line? So from B to C, what is the slope of the line? From C to D, what is the slope of the line? And what you need to remember is that in a velocity time graph, and that is why I asked you that you need to be very clear what kind of graph you are dealing with. if they give you a velocity time graph, the slope of the line would be the acceleration of the body. Are we clear till here?
Yeah.
So for example, let us understand this in detail. So for example, if they ask me that in this phase AB, what will be the acceleration of the body? So how I will find is, I'll have to find the slope of the line AB. The slope of the line AB is given by this formula, y2 minus y1 upon x2 minus x1. So what I'll do is, in this case, my A would be my x1 y1 and B would be x2 y2. Are we clear about this?
Yeah.
So if I have to find the slope of the line AB, what I need to do is, I need to find the slope of y2 minus y1 upon x2 minus x1. Are we clear about this?
Yeah.
And if you see, this is what I have done here. Is it making sense?
Yeah.
So if I have to find the acceleration of the body in part 1 of the motion, I have to find the slope of the line AB, which is given by the slope of the line y2 minus y1 upon x2 minus x1. Sanji, clear?
Yeah.
When they are asking me the acceleration in part BC, again I'll have to find the slope of the line. The slope of the line will be given by y2 minus y1 upon x2 minus x1. And in this case, if you see, the slope of the line is 0. And that is why the acceleration in this part of the motion is 0. The acceleration is 0.
Hmm.
But one thing that you need to be very clear, and that is where the maximum amount of confusion comes. The acceleration is 0, but if you see, the velocity is not 0. So this is a part of the lecture that most of the students find very, very confusing. That when they say acceleration is 0, they are not saying that the velocity is 0. What they are saying is velocity is constant. Are we clear about this or not?
Yeah.
Is it confusing?
No. Not much.
So the acceleration is 0, not the velocity.
Hmm.
Now if you focus on CD, if I have to find the slope of this line CD, again I'll do y2 minus y1 upon x2 minus x1, and that is what is being done here. And if you see, the slope is negative. The slope is negative, which means negative acceleration is called retardation. So specifically what is happening for this body is that AB, the acceleration is positive. BC, the acceleration is 0. In CD, the acceleration is negative. Are we clear about this?
Yeah.
All this information we have been able to find from the slope of these three lines. Are we clear?
Yeah.
Positive acceleration, zero acceleration, negative acceleration. Are we clear?
Yeah.
Okay. Now the second thing that we will have to understand is, when we see, I'm just taking the the case of the velocity time graph first. This velocity time graph first. The second information that we can get from a graph is the area under the line. They will say area under the line or area under the curve. Either of these two words are used. Usually till class 9th, 10th level, they use area under the line, and in 11th, they'll use the word area under the curve. Are we clear?
Yeah.
Now, before I start this, I'll just refresh the basic area formulas, because I've seen students don't even remember this. So just 30 seconds on the area. The area of a rectangle is length into breadth. The area of a triangle is half base into height. The area of a trapezium is half L1 plus L2 multiplied by D. What is the meaning of D? So for example, if this is a trapezium, this is L1, this is L2. So L1 and L2 are the lengths of the parallel sides of a trapezium, and D is the distance between the two parallel lines. One thing, are we clear?
Yeah.
I am only talking about the parallel lines. You need to understand that this information is about the parallel lines of the trapezium. Are we clear?
Yeah.
Any doubt earlier?
No.
Okay. So now let us come to how to find, when they talk about the area under the curve. The area in a velocity time graph gives the displacement. The slope under a velocity time graph gives the acceleration. The area in a velocity time graph, the area under the velocity time graph gives the displacement. बेटा उसको देखना, उसको देखना. Any doubt in here?
No.
Yeah. So now let us find. So for example, if I had to find the area of area under the curve AB, how I will find is half base into altitude. So this would be so what we have understood is that the area under the curve will give us the so for example, if I am looking at a velocity time graph, and if I find the if I calculate the area under the curve or area under the line, that will give me the displacement. So basically what I'm trying to tell you is that this is the displacement of the body from this time, sorry, from this time to this time. Is it making sense?
Yeah.
Similarly, when I'm looking at the curve, so from this time to this time, if I calculate this area, this would be the displacement that the body will be making. And similarly, when I look at or if I calculate the area under the curve between this time, from this time to this time, this would give me the displacement that the body would be making. And one thing that I'm repeating again and again and again is, you should be very clear with the kind of curve that you are dealing with. So before you start calculating the whatever information that is being asked, you should be very clear that I am dealing with a velocity time curve, because the second kind of curve which will be given to you would be a displacement time curve. And in displacement time curve, the slope of the line will be giving you the velocity. We'll discuss that in 5 minutes. So are we clear about the velocity time curves?
Yeah.
So let me analyze the motion of the body in this AB, and if I find the area under the curve, this area under the curve, this is a triangle, so the area under the curve would be half base into altitude. The base is 3, the altitude is 5, therefore 15 by 2 is a displacement that the body makes from A to B. Are we clear?
Yeah.
Second thing that we need to calculate is that what is the displacement that the body makes in this portion of the motion. Again, I have to find the area under the curve. And what I mean by the area under the curve is, what is the area under this line BC? Are we clear?
Yeah.
And because this is a rectangle, the area would be given by length into breadth. And the length into breadth is 4 into 5. And this is equal to the displacement. Are we clear? Avantika, any doubt?
No.
Now I'll try to explain something to you, check whether it is making sense or not. See, this part is time given in seconds. This part is in velocity, meter per second. If I multiply meter per second into second, I will get meters. And that is why the area under the curve is giving you meters. Is it making sense?
Sir, the whole video stopped actually. I couldn't hear anything.
Okay, okay, can you see the screen now?
Yeah, now I can see it. Now I can hear you.
Yeah, okay, not a problem. So the third thing that we need to calculate is, what is the displacement? What is the displacement from C to D? Again, I'll have to find the area under the curve, this.
Yeah.
And the area would be given by half base into altitude, because this is a triangle. Are we clear?
Yeah.
So if I find half base into altitude, this would be 10 meters and this would be displacement. Are we clear?
Yeah.
So using a velocity time graph, what we have been able to understand is, what we are able to understand is that if this is a velocity time graph and this is a line, then the slope of the line will give me the acceleration. The area under the line, the area under the curve would give me the displacement. Are we clear till here?
Yeah.
Okay. Another thing that we have understood is that we will be provided with these two coordinates. This would be x1, y1 and this would be x2, y2. Are we clear?
Yeah.
And in a velocity time graph, basically this one would be t1, v1 and this would be t2, v2. Are we clear?
Yeah.
Any doubt till here?
No.
Okay. Now let us see what is the information that we can find. What is the information that we can check out from a displacement time graph? Just to explain you things in some more clarity, we know that the acceleration is given by delta v by delta t. This is what we have done in the previous lecture.
Yeah.
We have understood what is delta. So this is v minus u upon t2 minus t1. So delta v is a change in velocity. We know that the change in velocity is final velocity minus initial velocity, and the final velocity is given by v and the initial velocity is given by u, and t2 t1 is the initial time and t2 is the final time. So t2 minus t1 is the time interval. Are we clear?
Yeah.
Now if you see this definition, when you see at this definition, and when we look at the definition of a slope of a line y2 minus y1 upon x2 minus x1, we see a similarity between these two formulas. Is it making sense?
Yeah.
And that is why the acceleration is given by the slope of a vt curve. Are you able to understand the connection between the maths and the physics?
Yes.
So similarly, if you see, velocity is given by displacement upon time. Is it making sense?
Yeah.
So displacement, see, I'm using s as displacement. So s in this case is displacement. It is not seconds, because here also there is some confusion, because usually you'll write meter per second. So students are usually in the habit of writing s for seconds, but here this s is displacement. So now if you look at the formula of delta s, that is the displacement would be given by v into delta t. Is it making sense?
Yeah.
And that is why velocity multiplied by time is the area under the curve of velocity time. Is it making sense now? Are you able to connect?
Yeah.
So that is why, okay. So that is why when you look at a velocity time curve, this is a velocity time curve. The area under the curve, this area under the curve gives me the displacement. Is it making sense?
Yeah.
So all I'm trying to tell you is that the connection between maths and physics, and why the slope and the areas of a velocity time curve are equal to the acceleration and the displacement. Are we clear till here?
Yes.
Now let us look at the simple case. We have gone through the tough part first. Now let us look at the simple case where we are given a displacement time curve. So s is the displacement. I repeat, s is the displacement. Now when I am given a displacement time curve, then the slope of the curve would give me the velocity. Are we clear?
Yeah.
Why? Because if you have understood the logic, this point would be t1 s1, this point would be t2 s2. The slope would be given by s2 minus s1 upon t2 minus t1 is equal to delta s upon delta t, and delta s upon delta t, displacement upon time, is velocity. So that is why if I am given a displacement time curve, the delta s upon delta t would be my velocity. Are we clear?
Yeah.
Okay. So this is all that the gyan that I want to share with you today.
Okay.
And when you look at these numericals, you will understand in the subject line displacement velocity time curves, displacement velocity time curves, this velocity time curve, meaning of the graph. When you see at these curves, you will understand that whatever we have discussed in the last 20-25 minutes is being explained with the help of numericals. Avantika, is it making sense?
Yeah.
And I'll send you this PDF also today. You can note down the questions that you can try to do. I'll mark the questions that you can do. Question number 2. These are solved examples, so you'll find the solution also, don't worry. Question number 3. Note kar lo beta. Note kar lo. Question number 2. Question number 3. Question number 2, question number 3. You can refer to the numericals also, that is not an issue. To the solution also, that is not an issue. Question number 4. I'll be sending you the PDF in the next 5 minutes.
Hmm.
Solved question 5. Solved question 5. These are class 9th level ICSE. So don't worry about the degree of difficulty. So question number 6th. Question number 6th. And question number 7. Have you understood?
Yeah.
So this is class 9th ICSE level. You would have done this, but you would have completely forgotten this. And as a matter of fact, yeah. And as a matter of fact, when they were explaining this in class 9, it would have gone over your head, at least 5 kilometers above your head. So whatever have I discussed when I send you the PDF, if you want to, just go through whatever have I explained to you. So if you see this section 2.6 displacement time curve, and when you look at section 2.7 velocity time curve, this is what they have explained. And when we meet on Thursday, this is this equation of motion part. This is what we'll discuss. But for that also, what you'll need to do is you'll have to see this 1 hour 28-minute video that I have sent you today.
Yeah.
This Avantika. Because in this lecture, the derivation of these 3 equations of motion is given. Because on Thursday, I won't be explaining you the derivation. I'll just start with the lecture, the numerical part.
Okay.
Yeah. Okay. So
Yes.
let's meet on Thursday, 4:45.
Okay, sir.
Yeah.
Thank you.
Yeah.